All right, so the last clip that you saw there messing with these things was getting the bearing housing off of the center hub there. We got that done, and I knew that these things were going to be very frustrating to deal with and to try to machine. And I needed to just go ahead and take the time without the camera rolling, with any distractions, without any distractions, and try to get one done. So that's what I've done. I've got one of these things machined right here, and we have got it machined to mimic the original VW size right there, except for this is 2 millimeter larger, which is a 42 mil, and then this diameter right here is also a little bit larger by 2 millimeters. I forget what that was, but I got it all wrote down, and I've got that so that will lightly press on to that journal right there. And then we had to turn this diameter here so that it will fit, and this flange diameter, so that it'll fit into the brake disc just like so. And then of course I've got the 4 by 100 millimeter bolt pattern drilled in there. And the welded up spot, I've got one of the holes kind of lined up on the where it's been welded up there. Just seemed to be the best place once I laid it out. And super hard. Everything about this is super hard. This is all hardened, heat treated and hardened steel, so it's extremely difficult to machine. And luckily I've got a couple of good carbide inserts that handle this hard stuff pretty decent, and I'm running the flood coolant on the Monarch as well, so that helped out, and we got one of them done. And I had spoke with the customer, and it's actually taking a lot more time than what I had originally thought was gonna go into it. I give him like an estimate. I said it might take this much time to do it, and it's taken way more time than what I thought. So I called him and I told him my concerns and let him know, and he come by here and looked at it, and he understands this is all custom stuff, and it's expensive. So he decided, let's just do two. We're just going to do two of these hubs right there, and he's gonna hold on to these two and keep those, and maybe do those at another time to kind of keep costs down where it's a little bit more affordable right now. So we're just going to do two of these. So we got one done. I'm going to show you machining the second one. There's a lot of squealing, there's a lot of coolant flying, so I'll try to get you a little footage of it and show you what it takes to do these things. So we're over here on the granite plate, and I wanted to use it in my height gauge to do the measuring on all these steps and all these flanges here from this face here, because what we're doing is we are going to be machining these hubs right here that you see me get the bearing housings off. So what we're doing is we're going to machine this to look like this, only we're going to be adding 2 millimeters to this diameter here, and in this first step we're going to make that 2 millimeters as well, larger. So I'm just going off of this flange height right here. You know, he said just from here up, just make it the same. So that's what we're doing. We're just measuring our links there that we need. And I'm using my Brown & Sharp height gauge. And I've already got I got the flange in the first two steps measured right there, and got everything wrote down. I'm doing a hand drawing right here so that I have reference to everything. And then once I get this drawn up and I get all my dimensions on there, what I'll do with this is take this and make a copy of it, so that when I'm out here in the shop using it, I'm not getting the actual drawing messed up and dirty. All right, so we'll go ahead and go up to our next step here. This one uses this knob right here to adjust the elevation, and just sneak up on it. All right, it's just now trying to go on there. We've got just a little bit more because it's got quite a bit of friction going up on that face right there, so just a little more. There we go. So now I'm sliding that across, and as I'm sliding it across there, I can feel both pieces touching. There's a little bit of resistance trying to go across that piece right there. So that's the measurement that I'm going to get, and I keep this pretty snug right there. And I have to really pick this thing up and read it, because I just can't bend down here and see that these lines are so fine right there. All right, we're at 1.534. All right, we got our touch just like we're supposed to right there. 425. I'm going to go ahead and write that down here. 0.425. So now we've got our distance from the flange to each step. Now I just got to measure all the way from here to here and see what that one is now. All right, so we can loosen this, and this one's got a little deal in the back. You squeeze it and it releases the threads, and you can quickly move it up. So we'll get up there really close to it. It's kind of like a half nut deal on the back side there. See right here. Just releases the nut from the threaded rod. Now we'll go on up. I'm going to snug this and make sure there's no movement there. I like that right there. I like it when you get just a little bit of friction touching there between the two. All right, so there's our heights to all of our flange, our faces there. And then of course I have the diameters written there, the diameters of all the steps. So on this one, I think what I'll start with is go ahead and get this side turned. So that way it gives me a little bit more area to chuck on. So let's do that first. We'll get it chucked up, and we'll just bump the face true there. All right, we got that face running within 1/1000ths there, so we'll go ahead and get this journal here turned down. Leaving enough so I can clean that radius up in the corner there. Just making it the same diameter as the other one there. Alright, we'll swap this tool. That should be on size. Let's give it a check. 2" 553 is what I wanted. And it's 2" 552.5 right there. Get my radius tool. Alright, so we can switch this around to the other side now, and that gives me just a little bit more area that I can chuck on. Makes me feel a little better, because that, you're going to see, this is really tough right there. This is hardened steel, and it is not fun to machine. Can't take very much at a time, and you got to turn slower. It just eats the carbide up in a second. So we're going to do the same thing there. I've got this chuck dialed in, by the way. I didn't show you all that. I use a gauge pin in there, and I go ahead and set it true. And then so I know when I go to chuck something up that it should be running true. So we're just going to focus on the face there. It looks like 1.5. Actually, that's probably the seal there. So I think the bearing is here and here. The race press is on. Okay, I think the bearing is right there. This must be the seal. Seal journal. All right, that looks like that's within 1/2 thousandths right there. I'm going to go ahead and make sure that the chuck is torqued well on all 3 pinions, and we're ready to turn. So the insert, the insert that I'm using to turn this is a Seco TH1000 is the grade, and I have found that this has been the best insert that I've ever had to turn hardened steel or any kind of hard metal. This has been a very good insert, and I've got 2 corners left. I'm still using the same corner that I used to turn that other one, although I can tell that it's getting a little wear. I can feel it with my fingernail. So we're just going to keep using it till it wears off. But that is an excellent insert for hardened steel, TH1000 grade. All I'm going to do is just touch the face right there, and that's going to be my 0 starting location. I'm actually going to move the carriage back because we're measuring from this face to the end for our end length there that we're going to do. Good old-fashioned analog readout right there. That's what we're using. So we're set to 0, and I'm going to go 1 inch 7/48 is what our length is. 1.7, and then we'll just go to 750 right there. So we'll go back to this side here, and I'm going to set this indicator to 0. So this is what we'll actually come back into for our finished face length. That one right there. It's a little soft right on the end, but it's going to start getting hard really quick. The shinier it gets, the harder it is. We'll have to slow it down. So this one distance here, I'm using this depth mic to check it and make sure that we're on. We've got our depth mic pressed up to the face. And I'm exactly 1 inch 750, so it's 2 thousandths more than what I spec'd out on the sheet, but 2 thousandths isn't nothing on that there. Good to go. All right, I got my earplugs in, and well, let me let it cool down just a sec. This is where I'm going to be using my coolant to try to save this insert as much as we can. Now it's getting into that radius. All right. So that's what I'm doing right there. We're taking a 16th at a time. notice right there the pitch changes. It's actually getting into softer steel. And the more we turn off, we'll actually eventually get past all that hard steel in that area and get down into some softer steel. Getting down to our finished cuts here. I'm hoping that hard spot cleans up. The other one did. Trying to get it from swinging over here on me. All right, let's see if we can get our radius cut in there now. Now we're out of the hard steel, we're into the soft metal. Just blending that corner together. Okay, I'm going to use that same radius tool, and I'm going to machine the next step, which is actually going to lower this down. This will be the shoulder for the bearing to press up against, but I got to bring it down a little bit. Let me get a zero started here. Hard stuff right there. All right, we got one more to kind of move a little bit. And it's that one right there. Let's see if we can move it in some. Here I'm using a ceramic insert to try to knock that little bit of high spot down where that hard area is. Looks like my ceramic trick worked. 654, it's right where I wanted it, so good deal. So our last feature of the machine now is just this outer flange diameter. It's going to be 120 millimeters. 4 inches 725 is where we're going to take it. Now that section there isn't hardened like that inner part of the hub. That's a 1/8 cut there. Getting into a hard spot there where that hole was welded up. Okay, finished cut right here. Nice interrupted cut with a hard spot, man. Just doesn't get any better, does it? Just got our chamfering tool, break these corners off. It's real close, but we can make it. We'll go to the bench vise over there and do our hand filing to get rid of all those sharp burrs there. All right, we got this thing filed, got all the sharp deathly burrs off there, and we've got the holes just kind of penciled in where they're going to be. So that's the only location that I can actually drill those holes. If you take it and try to position it somewhere else, it's going to line up with one of those holes somewhere. So we have to go through the area where it was previously drilled and welded. Drilled and welded up. And the problem with this area right here that I found out on this one is that weld is super hard, and a high-speed steel drill bit won't touch it. So for this one right here, this hole, I end up having to use, this is the only drill I got in the shop that would actually do this. This is my 1/2 inch carbide straight flute drill that I use to drill that hole right there. And luckily the stud will still press in there. It'll still press into the serrations right there. The other holes that I drilled, we'll drill those 12.5 millimeter. That'd be a little bit smaller, but the 1/2 inch still will work for pressing in that stud right there. It'll still press in. That's the only drill I got. You know, if I had a 12 or 12.5 millimeter carbide, we could use that, but this is the only one I have in the shop, is this 1/2 inch. Just unfortunate that turns super hard right there. It's just because the weld gets in. This is a heat treated part, so it's tough, and that weld gets in there and it just turns hard. So I didn't want to do any annealing on these parts. I wanted to keep the strength in there from the manufacturer like they are. You could heat this thing up and soften it, but I didn't want to go that route, so we're leaving it just like it is. So we're on our last step. We'll set up in the mill and do our 4 by 100 millimeter bolt circle right there. I wanted to show you that too, I forgot, but if I spin the spin the rotor on there, you can see what I mean by no matter where you go besides where I've got it clocked there, you got 4 places. But if you try to move it off that weld hole, see, you start getting into a hole there, you're going around a little more, then you start getting into that hole, move around a little more, you get into that hole. So that's the only spot that you can actually drill that. You can move it just a little bit to either side, but you're still going to get into that welded section there, because if you go over too far, then you start getting into the other holes. All right, clamp down to the mill. I've got the holes positioned where I want to, and we're going to use our Blake coax to find the center here. Real high that way. Just little movements at a time. Yeah, that's pretty good right about there. That's within 1/1000ths of being center. So we'll zero out the digital readout, and then we'll program our hole pattern. All right, we're zeroed up. That's our starting location. So we're going to hit function, pitch circle diameter. We're going to hit enter, go in there, enter. So we're just going to cycle through. So I've already programmed this in there. 100 millimeter, we'll just go ahead and do it again. 100, enter. 4 holes, 4, enter. Start angle, doesn't matter. We can start on 0 or 90 degrees or 180, it doesn't really matter. So we're just going to start on 0, enter, go. So 50 millimeters to the side, and that'll be our hole number 1, and then we can cycle through all 4 holes. You can go to any one you want at any time. All right, so I'm just going to spot the hole in first, get it centered. So the drill bit that I'm using for this is 31/64. That's 485 thousandths. That's also around 12.3 millimeters. So that's according to the specs for the stud that I was given, the hole is supposed to be somewhere around 12.2 millimeters. So this is right around the perfect size for that. Only other size I have would be 12.5 millimeters, which would work good also, but this actually puts it closer to the spec size for that size stud there. So it'll give it a few thousandths interference press fit into that hole. Just using some of my dark cutting oil here like I normally use. This is some pretty tough steel, so this isn't hardened out here, but it is heat treated. So it's not hard and it's not going to dull the drill, but you don't want to burn it up by going too fast. So I'm running 325 RPM. And we'll go ahead and break that edge with a chamfering tool while we're set up above it there. Just touch it. All right, we'll move over and we'll do our next hole. We're going to do the hard hole last. Okay, so now we're on our last hole. So now we're using our 1/2" carbide straight flute drill bit. You can see by the chips right there just how hard that is. You got to be careful when you go through with it too. You don't. I lock the quill so that it can't snatch the quill down and break the drill trying to come through. So there you go. That's why I say you got to use a carbide there, because that was just super hard there. Just going to use this deburr tool here for the back side of the holes. It's like a chamfering tool. One time around does a great job on it. You got to be careful not to actually push in too hard, because this thing really digs in. I'm not going to do that hole because it'll actually put some dull spots there on it. There we go. This guy is finished right here. Let's make sure that our rotor is going to line up with the hole pattern. Everything looks good. Perfect. All right, guys. So this job is now done, doing what I needed to do with the two hubs here. We've got the two completely machined, and then we've got two that he can take, and if he decides later that he wants to do two more, he can bring them back. And so we already got them apart. You know, we figured out how to get this bearing housing and bearing off the hub. So in case you missed it, I don't know, this is throwaway. This is not going to be used for anything. So it was just getting a hold of these hubs that's giving him what he wants, because he wants to run this larger GM axle right there with the larger hub right there. He was saying that the factory Volkswagen size axles are breaking. Apparently they're putting like 500 or 600 horsepower in these Volkswagens, and they're breaking the axles. So this is something that they're trying to do to increase the strength of the drivetrain there. And I guess that's just how it goes with the automotive world when you're doing drag racing and custom, is trying to beef things up. So this is not on-road applications. This is just drag racing stuff right here. All right, so I'm gonna call him and let him know he can come pick this stuff up, and we'll see you on the next job, okay?